In section 5.8, you are going to be simplifying radicals. If you look at the box, the gray box on page 344, it says this: a radical expression, such as 2 times the square root of 3, or the square root of x plus 3, is an expression that contains a radical. That means a squared root. A radical expression is simplified if the following statements are true. You need to memorize these. A radicand has no perfect square factors other than 1. The radicand contains no fractions. And no radicals can appear in the denominator of a fraction. What that means, I will explain all these in a little easier terms. The first one, the first bullet, means that underneath the squared root, you cannot have a factor of that number be a perfect square. So off to the side, on page 344, write these. You need to write perfect square numbers. You have to memorize these and know these by heart. For example, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and so on. And these keep going. All of these are perfect squares. If you have a number, for example, the squared root of 20, if any of these numbers here are a factor of any of the numbers underneath the squared root, it is not simplified at all. So the square root of 20, what you are going to do is this. You're going to have to rewrite it into the square root of 4 times the square root of 5. Why? Because the square root of 4, right here, is a perfect square. Because I can now simplify that. The square root of 4 is 2. The square root of 5, I cannot do. So my answer would be 2 square root of 5. That's what the first bullet means. The second bullet means this. You can't have that. You cannot have a fraction within the square root. Now in this problem, to simplify it, you would just take the square root of 4, which is 2, the square root of 9, which is 3, and there's my answer. And the last one would say this. You cannot have a squared root in the denominator. A square root in the denominator is almost like illegal in math. You cannot have that. So look at what it gives you as an examples of simplified and not simplified. The not simplified. Square root of 12, because 4 goes into 12. The square root of x over 2, because you're taking the square root of a fraction. You can't have that. And the last one is because there's a square root in the bottom. Now we're going to go through how to get rid of all of these. But I'll be honest, this is going to be a challenging chapter. The work isn't hard, but there is a lot of stuff that you have to memorize. All right. So at the bottom of the page on page 344, it says multiplication property of squared roots. It means this. If you have the square root of AB, I can separate that into the square root of A times the square root of B, such as this, the square root of 48. Now, if we look over here again, is there any one of these numbers that goes into 48? A lot of you would say 4. 4 goes into 48. But that is not the biggest perfect square. 16 is the biggest perfect square that is a factor of 48. So you have to break 48 into the square root of 16 times the square root of 3. The square root of 16 becomes 4, and the square root of 3 comes down. So your answer would be 4 square root of 3. So let's start going to page 345 at problem 1. So the square root of 72, if we're talking about putting square root of 72 in simplified form, the square root of 72 we have to break down into a perfect square that goes into 72. Now we know, for example, a lot of you would think 9. I can break the square root of 72 into the square root of 9 and the square root of 8. But the problem is that number, the square root of 9, is not the biggest factor that goes into 72. So what you have to do is think of a bigger factor that you can take the square root of, and that number is what you're going to break 72 down into. So 72, the biggest factor that you can take the square root of 72, the square root of, would be 36. The square root of 72 can be broken down into the square root of 36 times the square root of 2. Now simplify it. The square root of 36 is going to give you 6. The square root of 2 you cannot do. So my answer would be 6 times the square root of 2. So in problem number 1, we have the square root of 225. The square root of 225, we can just simplify. All it is 15. We're done. Number 2, negative 4 times the square root of 117. Now, you may look at 117 and go, I don't know what's in it. So once again, you have to just think of numbers. What is a factor of 117 that you could possibly take the square root of? Well, what I look at is I see that 7 plus 1 plus 9, or 7 plus 1 plus 1 is 9, and 3 goes into 9, so 3 actually goes into this number. So, but 3 is not a perfect square, so I'm going to see if 9 works. 9 does work. So I'm going to break the square root of 117 into the square root of 9 times the square root of 13. The square root of 9 is 3. The square root of 13 you cannot do. So now I can take negative 4 times 3. That gives me negative 12 times the square root of 13. So my answer would be negative 12 times the square root of 13. Let's do a couple of more examples. I want to do a few more because I'm not confident with just these few examples. So I'm going to do 2a and 2b. Let's do negative 5 times the square root of 50. What is the biggest number that you can take the square root of that goes into 50? Be 25. So I can break the square root of 50 into the square root of 25 times the square root of 2. The square root of 25 is 5. So now I simplify, my answer would be negative 25 times the square root of 2. The next one, negative 2 times the square root of 500. Well, I'm thinking that I can take the square root of 100. So I'm going to break this up into the square root of 100 times the square root of 5. Now I'm going to skip a step, which you can do. The square root of 100, what is the square root of 100? It's 10. So then I take 10 times the 2, the negative 2. That gives me negative 20 times the square root of 5. So my answer would be negative 20 times the square root of 5. In this next session, we have to remove variables as well. Now, if you look at the gray box at the top, it says that a variable with an even exponent is a perfect square. And what I mean by that is this. That is not even, you cannot do that. So if you had the square root of x to the 8th, that would just be x to the 4th. Because remember, you add the powers, you don't multiply them. So you are not thinking what times what gives you 8. You're thinking what plus itself gives you 8. The square root of y to the 16th would be y to the 8th. The square root of z to the 10th would be z to the 5th. The square root of, for example, x squared y to the 20th would be the square root of x, I'm sorry, not the square root. The square root disappear. You get x y to the 10th. The problem becomes is when you have that. And here's what you do. All you do is subtract 1. So you would get the square root of x to the 8th times the square root of x. Square root of x to the 8th is x to the 4th. And the square root of x you cannot do, so you get that. So let's look at the got it. The got it is negative m times the square root of 80 m to the 9th. You have a lot of stuff going on here. Negative m times. The square root of 80 can be simplified into the square root of 16 times the square root of 5. M to the 9th is an odd power, so you have to subtract 1. So that would be m to the 8th times the square root of m. So that would give me negative m times 4 times the square root of 5, which I cannot do, times m to the 4th times the square root of m. And now we got to put them together. All these right here have to go on the outside. So negative times 4 will give me negative 4. M to the 4th times m will give me m to the 5th. Add the powers. And then underneath the square root, we get the square root of 5m. So my answer would be negative 4m to the 5th times the square root of 5m. Example number 3 and example number 4. The square root of 50 t to the 5th. The square root of 50 is going to be broken down into the square root of 25 times the square root of 2 times, we subtract 1, the square root of t to the 4th times the square root of t. The square root of 25 is 5. The square root of t to the 4th is t to the 2nd. These two numbers go out front. These two come down into the square root since you can't do them. And my answer would be 5t squared times the square root of 2t. Number 4, negative 2 times the square root of 243 y to the 3rd. The square root of 243. Let's see, what could go in the 243? It's going to be 81. So you have to break that up into 81 times the square root of 3. Subtract 1 on your y, so it'll be y squared times the square root of y. The square root of 81 gives you 9. The square root of 3 stays the same. The square root of y squared is just y, and times y. All of these have to go on the outside. Negative 2 times 9 is negative 18y. And these stay inside the square root of 3y. It's going to take practice. This stuff is not easy. The math itself isn't hard. It's just remembering what to do. There's a lot of steps. In the next section, you are going to be multiplying two radical expressions. So we're going to look at our got it. The first got it is 3 times the square root of 6 times the square root of 18. Please, please, just multiply them first. Here, you multiply the numbers on the outside, 3 times 1. That just gives you 3. You now multiply the numbers on the inside, 6 times 18. 6 times 18 gives you 108. So we get 3 times the square root of 108. But then you got to simplify. 3 times and 108, let's see here, can be divided by, let's see, it's 9. But I think we can have a bigger number here. 36. So we can break it up into the square root of 36 times the square root of 3. Because once again, 36 is a perfect square. So that's what I have to use. 3 times 6 times the square root of 3. My answer is 18 square root of 3. B. The square root of 2a times the square root of 9a to the 3rd. If you multiply them together, you get the square root of 18, a to the 4th. The square root of 18 is going to be broken up into the square root of 9 times the square root of 2. The a to the 4th I don't have to even do because it's odd, or it's even. Because it's even, I don't have to do anything with it. The square root of 9 is 3. The square root of a to the 4th is a squared. I put these two out front. My answer will be 3a squared times the square root of 2. C. 7 times the square root of 5x times 3 times the square root of 20x to the 5th. 7 times 3 is 21. 5 times 20 is the square root of 100, x to the 6th. 21 times, well, the square root of 100 is just 10, and the square root of x to the 6th is just x to the 3rd. 21 times 10 is 210, x to the 3rd, and that would be my answer. If you understand it now, you can skip this next problem. Otherwise, I am going to do one more here, number 5. Number 5 says 10 times the square root of 12x to the 3rd times 2 times the square root of 6x to the 3rd. Let's multiply them together. 10 times 2 is 20. 12 times 6, 60, 12, that'd be 72. X to the 6th. And remember, add powers. What is the biggest perfect square that goes into 72? It'd be 36 times the square root of 2. This is already even, so I don't need to do anything with it. Now let's simplify. 20 times 6 times the square root of 2 times x to the third. Everything that's not in the square root goes out front, square root stays at the end. So that would be 120 x to the third times the square root of 2. We are skipping problem 4 right now because that section requires us to use Pythagorean theorem, and that's something that you haven't had, and the book expects you to already know it. So we will come back to that later in this later next quarter. Problem 5. Now, this is going to get a little trickier. In the gray box above problem 5, it says that you can also simplify by using the division property. Here's what the division property states. If you have the square root of a fraction a divided by b, you can separate it into the fraction square root of a divided by the square root of b. For example, the square root of 36 divided by 49 is the same thing as the square root of 36 and the square root of 49. You can just take the square root of the top and the bottom. Your answer would be 6/7. Then it says, when a radicand has a denominator that is a perfect square, it is easier to apply the division property of square roots first and then simplify the numerator. When the denominator of a radicand is not a perfect square, it is easier to simplify the fraction first. So, this is going to take some practice. It will get easier, but I promise you that you got to stick with this. It's going to be difficult. The square root of 144 divided by 9. Now, here's what it says. If the bottom is a perfect square, just simplify it. In this problem, you can take the square root of both 144 and 9, so we can just do that. So the square root of 144 is 12, and the square root of 9 is 3. That means 12 divided by 3 would give us an answer of 4. Now you could have, if you wanted to, divided 144 divided by 9 and gotten the square root of 16, which is also 4. You can either simplify the fraction first or take the square root of the bottom. B. B is the square root of 36a over the square root of 4a to the third. Here's the problem. First, now I rewrote it like this. I want you to simplify, I'm going to rewrite it as the book here, 36a divided by 4a to the third. Here's our problem. The square root of 4, I can do that. The square root of a to the third, I cannot. So we want to simplify this fraction. 36 divided by 4 is 9. A over a to the third. Where are there more a's? On the bottom. So if I simplify my fraction, I get this. I now can take the square root of a to the second and the square root of 9. The square root of 9 is 3. The square root of a squared is a. So my answer is 3 divided by a. Part C. The square root of 25y to the third divided by z squared. The denominator is a perfect square, so I'm just going to simplify it. The square root of 25y to the third over the square root of z squared. The square root of z squared is just z. The square root of 25, which I can do, is just 5. The square root of y to the third has to be broken down into y squared and the square root of y. The square root of y squared is just y, so my answer will be 5y times the square root of y over z. And remember, you can have a square root on the top of a fraction, but not in the denominator. This is the hardest part. The gray region on page 349 exclaims this. When a radicand in a denominator is not a perfect square, you have to rationalize the denominator to remove the radical. To do this, multiply the numerator and denominator by the same radical. And you should choose an expression that makes the denominator a perfect square. It may be helpful to start by simplifying the original radicand in the denominator. Excuse me. I'm going to do a few off to the side. So somewhere if you have blank room, write this. We're going to do a few easy ones to get you started. So let's start with 3 times the square root of 5. You cannot have a square root in the bottom. And if you remember from any rules of fractions, you can do whatever you want to the fraction, but whatever you do to the bottom, you have to do to the top. I have to make the bottom a denominator that is a perfect square. So when I see a square root of 5, I realize, okay, well, I can multiply this on the bottom by the square root of 5, because that's going to give me the square root of 25. And I can do that. So if I multiply the bottom by the square root of 5, I have to multiply the top by the square root of 5. So on top, 3 times the square root of 5 is just 3 times the square root of 5. Square root of 5 times the square root of 5 is square root of 25. And now I have to simplify that. 3 square root of 5 over 5. 3/5 can't be simplified. We do not have any square roots in the bottom. And 5 is simplified right here. There's no perfect square that goes in there. So this is my answer. Let's try another one. Let's try 5 square root of 2 over the square root of 8. In this problem, I cannot take the square root of 8. So what I want to do is I want to make it a perfect square. So I'm thinking, okay, I can take the square root of 16. So I'm going to multiply the top and bottom by the square root of 2. That would give me on top 5 times the square root of 4. On bottom, the square root of 8 times the square root of 2 is the square root of 16. Now, once you start getting used to this, you can start skipping steps. I know on top, the square root of 4 is just 2. On bottom, the square root of 16 is 4. So that means my answer is 10/4. 10/4 I can divide by 2. My answer is 5/2. Let's try another one. 6 over, let's do the square root of 50, x to the third. On bottom, I'm thinking, what can I take the square root of that's a perfect square that 50 could go into? Well, I could make it 100. So that means I'd have to multiply the top and bottom by the square root of 2. But I need to make the denominator with the variable an even power. You've got to have an even power. So if it's not even, you just multiply it by an x or a y. If it is even, you don't do anything. So on top, I would get 6 times the square root of 2x. On bottom, I would get the square root of 100, which you can just skip this step if you know what the square root of 100 is. It's going to be 10. And then x to the third times x is x to the fourth, and the square root of x to the fourth is x squared. But we're still not done, because right here I have 6/10. 6/10 can be divided by 2. You're going to get 3/5. The square root of 2x cannot be simplified. X squared stays on the bottom. Now someone might say, Mr. Humphreys, why can I not simplify this x and this x squared? Because this is inside the square root. This one's not. You can't simplify things inside and outside the square root. So let's do our got it problem. The square root of 2 over the square root of 3. The square root of 3 I cannot do. So what could you multiply by it to give it a perfect square? Well, I can make it 9, which I can take the square root of. So on top, the square root of 2 times the square root of 3 is the square root of 6. The square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 becomes 3. This is very tricky. You want to look at this and say, oh, I can simplify that. No, you can't. Square root and outside the square root, you cannot simplify things. So that is your answer. The square root of 6 divided by 3. The next one. What could you multiply to 18 to make it a perfect square? Well, I'm just trying out numbers now. 18, I'm just guessing things. 18 times 3 is 54. That's not a perfect square. 18 times 4 is 72. Not a perfect square. And you can just keep practicing or keep going until you find something that you can take the square root of. I just kept going. I'm taking 18 times 5, 18 times 6, 18 times 7. And then once I multiplied by 8, I realized that 18 times 8 is 144, and I can take the square root of 144. My suggestion would be this. Memorize all of your squared roots up into 15 times 15, which is 225. You will get better at it anyway, but I would remember like what 2 times 2 is, 4 times 4. Those are easy. But make sure you know what 11 times 11 is, 12 times 12, 13 times 13. It will make your life easier. Okay, the m here is odd. I don't want odd, so I just multiply by an odd. So here we go. The square root of 5 times the square root of 8, m would be the square root of 40m. Over 18m times 8m in the square root will give you a square root of 144m squared. Simplify. The square root of 144 is 12. The square root of m squared is m. But we are still not done. Here's why. That 40 is a red flag. I can break the square root of 40 down into the square root of 4 times the square root of 10. And then the m just stays there. The bottom is just 12m. The square root of 4 is 2 times the square root of 10m, divided by 12m. I'm still not done, because I can simplify 2/12 into 1/6. So that would be the square root of 10m divided by 6m. So my final answer is the square root of 10m divided by 6m. And C. I'm going to break this up into the square root of 7s divided by the square root of 3. I'm going to multiply the top and bottom by the square root of 3. That gives me the square root of 21s divided by the square root of 9. The square root of 9 would just be 3. Once again, I cannot simplify 21 divided by 3 because one's inside a square root, one is not. I'm going to do the next two. If you think you got it and you're done, you can stop the video. Otherwise, for more practice, I'm going to do these two. 1 divided by the square root of 11. I'm going to multiply it by, if you do 11 times 2, 3, 4, 5, 6, none of those are perfect squares until you get 11 times 11. 1 times the square root of 11 is just the square root of 11. The square root of 11 times the square root of 11 is 121, which the square root of 121 is 11. So my answer is the square root of 11 over 11. Number 12, 8 times the square root of 7s divided by 28s to the third. The next one, I can multiply 28 by 7. That's going to give me a perfect square. And since I have an odd power, I multiply by 7s. So on top, I would get 8 times the square root of 49s squared divided by the square root of 196s to the fourth. On top and bottom, I can simplify. The square root of 49 is 7. The square root of s squared is s. The square root of 196 is 14. And the square root of s to the fourth is s squared. That gives me 56 s over 14 s squared. I can still simplify this. Divide by 7. That would give me 8 over 2, which I can still simplify because 56 divided by 14 is just 4. And then where are there more s's? On bottom, one more s, so my answer is 4 divided by s. There is a lot of work here. Just keep practicing, just keep working through this, and this will get easier.